Hello all, we are solving Leetcode weekly contest 483 and the problem is minimum cost to make two binary strings equal. So we are given two binary strings S and T and we have to make them equal using the following three operations. And the three operations are flip cost, that is select an index I and flip Si or Ti. If it is 0, make it 1. If it is 1, make it 0. Another is swap cost, that we select two distinct indices I and j and swap S of I with S of j or T of I with T of j in either of the string. Another is cross cost. So in this, we simply swap S of I with T of I, same index but in different strings to return the minimum total cost needed. So it was not an easy problem, it was on the little bit on the hard side. What I did is basically initially I took Z and 1. Z is my 0, 1 is 1. I calculated for the mismatches, like for S of I not equal to T of I. And if S of I is equal to 0, incrementing Z, if not, it is 1. So I just calculate how many mismatch pairs are there. Now, there are three ways possible to finally conclude an answer. That is, if for the mismatches, simply do the flip cost in either of the string and you get the answer. So that is my one probable answer. Because the flip cost, swap cost and cross cost, they may vary in numerical. So I have to compare three of them. Another is arrange the minimum of 0 and 1 mismatch to the right location and then leftover can be done using the flip cost. So this was our answer 1, that is we took the flip cost into Z and 1, that is the total number of mismatches. Another one is we take the minimum of Z and 1, that is we try to sort it the minimums of Z and 1, the unmatching pairs using swap cost and then the remaining one with the flip cost. So for example, I have 0 and 1 and 1 and 0. In one operation, I can swap it and it will become 1 0 1 0. And if it was an odd, let's say I had another one or not specifically odd, there were more matching pairs. And since it is minimum, so there will be leftovers and they can be simply handled using the flip cost, right? Another is cross cost. That is answer 3. This is a bit important one. It helps in balancing zeros and ones and it alone cannot be done. It needs swap cost. So what does it mean? Basically, what I'm doing in cross cost is I am making changes to Si and Ti. And in order to make them equal, I need to have equal number of ones and zeros on both the ends on S and T. So for that, I need this cross cost. And after making them equal, if you see this example carefully, what I did is basically I transported this one to over here. I did it two times because if I have four mismatches, if I'm doing it for two number of times, I will get to the right conclusion, right? So here if you see, I have taken the minimum of Z and 1, multiplied into the swap cost. Similarly, as the previous one, that how we handled arrange the minimum 0 and mismatch to the right locations, right? So we make it to the right locations, minimum of them. Now the leftovers, that is absolute value of Z minus 1 by 2. By 2, why? Because we are dealing with 2, because we are swapping it. We are making 1 to 0, 0 to 1. So at 2, in one operation, we are handling twice. That is why Z minus 1 by 2 and alone cross cost won't help. I need to swap it to the right locations. So that is why cross cost plus swap sort. Now there's one more case. What if I, since we are doing it by 2, what if it was odd? Absolute value of Z minus 1 was odd. In that case, I need to handle it using the flip cost, that if the left is there in leftover, then simply answer dot 3 plus the flip cost will give me the final answer 3. And finally, what I'll do is I will return the minimum of answer 1, answer 2 and answer 3 as my answer. So this was all for this question. If you have any query, do comment it out. If you want to make a detailed video, I can work on that and I will do it. Just simply comment it. And if you like the video, hit the like button and do subscribe for more daily content. Thank you.